All right, I should be live right now. You should be able to hear me. Welcome. I know no one's watching yet because there's just one viewer. That's probably just me in the other window. Let's talk about what we're going to be building today. Here we are. How do I explain this? So what I was thinking about is something like Anki. I don't know if you've used Anki before, but it's this spaced repetition learning tool where you have flashcards that you can study yourself, train with yourself so that you can study something of your choice. And it has these cards, and they're all put in an SQL database with an unknown format. So this is the overview of Anki. If you click on German, which is my little study deck as an example, I can click study now and I see a card. I click show answer and then I get to say, was it hard, was it fine, was it really easy, or was it wrong? Do I need to start again? So because I want to learn German, I want to do this right, and I want to do it in a way that motivates me to learn German. And the thing that doesn't motivate me about Anki is that I'm not really sure that I'm not going to lose my progress. That's one. And the second is that the only way to create these decks is by clicking add here, and then making these cards in this GUI. And this doesn't allow me to have my cards somewhere in a Git repository so I can work on it and be proud of it. And the only way to really get something future-proof out of this is by clicking export, and I would have to do that every time. So what I don't like here is that it's not declarative. The cards are not declarative, and obviously there is a lot to this that I haven't really explored, and I'm guessing we're gonna explore that today. So I've got some ideas, and I want to get something really basic started today. So let's have a look at what I want to build. I'm opening a small file here just so we can talk about what needs to be done. I started on something really simple called Spirep, which is going to be the project that we're going to be working on. It's basically a proof of concept for now, but we'll see where it goes. And I'm opening my small file here to see what needs to happen. So what I want to happen in this stream is to make a little TUI and have it be able to see a bunch of cards in text files. I don't know what kind of text files yet, but declarative files. So pointed at some sort of collection of cards, and then have it store the repetition data in an SQLite database. And then eventually what I want to happen there is that I can sync this SQLite database with this little server so that I can train from anywhere and have my repetition data be synced. And the repetition data should reference the cards in a way that makes sense, sort of. So, and the only way I can think of to make that happen is to have a content addressable hash. To have the cards be content addressable so that I can point to them via the contents from the SQLite database that contains the repetition data. So I'm hoping this won't take too long, and we'll see where we get. So what I've already got is a little file that says this is what cards are. They have a front text and a back text, and there is a data structure called card definitions, which is just going to be a deck, let's say. Maybe I should call it deck. Anyway, so this is what's going to be in the file, and then I've made my little example vocabulary, which I got from going through a book that I got from the Money Museum, which is called Das Geld. And I've got some words in there that I didn't understand, and so I looked them up, put them in here, and then I can study them. Now obviously this is not necessarily fun to write, so we might want to make an editor for that, but we'll get there. Why did I put reverse here? I think the idea here was that I don't just want to study the cards front to back, but also back to front, and maybe I want a deck level Boolean flag that says whether that's going to be the case. So let's get started with this. The first step will be to, well, we have the first step, which is to be able to read in the cards. The second step will be to have a TUI to scroll through the cards. And this will just be show each card one at a time, not even front back. And then TUI to scroll through to study cards without the repetition data. And then the next step will be TUI with repetition data. So that's the plan for today. I think if I can get this done, this will be already plenty of stuff to do. Just checking if anyone else is planning to join. It would be nice to do some pair programming. All right, so let's get started. This is the first step we want to make. We want to take English. Okay, so a little TUI to scroll through the cards. Luckily, I've got this little repository which is called TUI base. Come on, internet. Why doesn't this work anymore? Something seems to be wrong with my Firefox. There it is. And now it's gone again. So I've got TUI base. Which is a little template repository that I once made when I gave this talk about building terminal user interfaces. I can highly recommend it. I'll put the link to this in chat in case anyone is interested. And then you can also have a look at this lecture if you like. Oh, nice. So, I'm gonna steal the contents of this so that we have a little TUI to start from. And I'm gonna put this in a separate module first. We don't need the card definitions right here, right now. Okay. And this SIF alias is just stack install file watch. Makes it easy to get started on something. So this is all we need here, I think, and then we can remove that. Alrighty, so if you don't know how Brick works, it's not that difficult, to be honest. I'm just gonna copy paste this so you can see what happens. And then we need a whole bunch of imports. I'm just gonna do it this way and have the compiler tell me which ones are redundant. There's nothing else interesting in that little module. So here we go. So in the TUI in the TUI template repository, what happens is at some point you build an initial state for the TUI. Then there is a little Elm architecture loop that happens. So you give the TUI to Brick. Brick draws the TUI to the screen, the TUI state to the screen. And then whenever an event happens, which is when someone presses a button or a whole bunch of other examples that you could have, the next state gets produced or not in the case in the case where you halt. And then control gets handed back to here and you can have a final state. So what we're going to try and do now is have the deck of cards be available to the TUI, and then just go over them one by one. Now, what you remember in the state, what you should be remembering in the state is probably where you're looking in the deck. So which card you're looking at currently and whether you're looking at the front or the back, or the front or both, I mean. So let's get started with that. The thing you need to know whenever you make a TUI is about the concept of cursors. A cursor is, I've said this hundreds of times, a cursor is a data structure that represents both the entire thing that you're looking at and where you're looking within the thing. So in this case, we're going to have a list of cards that is non-empty. If you have no cards, then it doesn't make sense to do these repetitions. And if it's non-empty, that means you could be looking at one of the elements. And this is the cursor we're going to be using. It's called a non-empty list cursor, where you're looking at an element and there are elements before and after. They can have different types for reasons that you don't need to know about right now. So we're going to be using the simple list cursor. There we go. So we will need this module, and that's just where there's two. The simple list cursor is just where the two parameters are the same type. And then we're going to want to put a simple list cursor of cards in our state. I'm going to put this on a separate screen. So we have our cards here, and we want to put them in the cursor. So let's call this state instead of TUI state. Actually, let's not call it state. Let's call it S state, as in S for spaced repetition. Why not state? Because there's the state transformer with the identity functor, which is also called state. And I don't want to run into any of those issues later on, even though we're probably not going to be using... Actually, that's stupid of me. We're not going to be using a state transformer, so I might as well just call it state. It's going to make things a lot more clear to think about. So we have a cursor of... a non-empty cursor of card defs. No, card def. Yeah. We'll probably rename a lot of these soon, but this is good for now. Let me get some coffee. Any questions so far? I see that there are 3 people watching. I think I'm one of those, but that's fine. So if you have any questions, put them in chat. If you would like to join for some pair programming, feel free. We'll arrange it. All right. So I also need to put brick and vty in my dependencies, and then also directory. I don't know why I need that, but it's not a big problem. It's a transitive dependency anyway. Okay, so now that I've put this in the state, I've basically decided this needs to be in the state. Now I just need to fix all my type errors and I should have a working state. So I think building the initial state is gonna take the path to the deck, or the card definitions rather. And then I can do this. Now I should get maybe card defs. If it's nothing, I'm gonna die. It says file does not exist. Okay, so we've got this list of cards. Now I'm going to turn it into a cursor. There is this make non-empty cursor, but it takes a non-empty list, so we need to import data.list.non-empty, and then also import the same module again, so I can use it qualified. Next up, we're gonna turn this list of card defs into a non-empty list. There we go. So any.nonempty of card defs cards. If it's nothing, I'll say, and it's fine to die here because this is just when we're building the initial state. There's nothing special going on beforehand. No cards to study. And this is all wrong in the long run, but it's fine for now. So we've got our non-empty list. And then we're going to turn that into a non-empty list cursor. There we go. And we're going to put that in a state. I'm going to do it like this because I'm assuming there are going to be more things in the state soon. And die comes from system exits. Now, build initial state will need this path, like so. All right, so now if we run this, it should crash because we have no image yet. So if I now try and run this, it says empty picture, and that's indeed what we want. So now I'm going to have to somehow draw this state. And because we have a cursor here, that means we know which card we're looking at, and we're only going to be showing the card that we're looking at. So we can ask for the current element in the cursor. And there must always be one, because it's a non-empty cursor. It's a cursor for a non-empty list, rather. And then we're just gonna show both the front and the back. Let's start with the V box, that's a vertical box of things. And we can say txt of, and the current card, I think we can do card def, like so. Card front. Does that work? Oh yeah, there's something wrong with the list, but I'll get to that in a moment. Okay, so the thing is, here, when you draw the TUI, it expects a list of widgets instead of a single widget, and that's because you can have multiple layers on top of each other. But in our case, we're just going to have one layer, so I'm just going to put that in a list like so. And this is a text that needs to be turned into a widget. There we go. So now we've got the first element in the list right above each other. And I can press Q to stop because that's what I've defined here. And here we see the end state, which is just the state with that cursor. So nothing special so far. The next thing we want to do is be able to cycle through them. So I'll say, I'll just have it cycle front to back, and then we'll make it pretty in a moment. Actually, no, let's commit this already. We don't want to mention these. The smalls file is fine, I think. No, actually, I don't want to put the smalls file here. Just gonna put that in my own workflow so that no one else has to see that. Okay, got it. All right. A little TUI to show the first card. First step, done. Okay, next up is we want to be able to scroll through the cards, and once that's done, I've got this first to-do over. So, how do I want to scroll? I'll say left and right, and then also L and H. We want to have some function to go to the next one, and I know that non-empty cursor select next will return a maybe because it will be nothing at the end of the list. What do we do at the end of the list? I'm not sure yet. Actually, let's say key right here. We only need the right at the moment. And this will be wrong in a moment as well, but we'll get to that. So what we want to do here is create a new S, which is S with a different cursor. And this different cursor is going to be first we need to try and change the cursor. So we change the cursor by using non-empty cursor select next, which turns it into another cursor which represents the list, but looking at the next element. If that's nothing, then I guess we'll just halt for now, that's fine. And if it is the next cursor, then we can put that back into the state and continue. There we go, now we can scroll through. Cool. And then because I want to make it a little bit prettier, let's try and do that as well. So let's go to brick and make it a little bit prettier. There is some core, voila. That's probably the one we want. And now what do we want to have difference? Let's say we want a big border around the entire thing, and then I also want an H border in the middle of the two parts. That's brick widgets border, I think. Yeah, that's sort of what I want. And now I want them centered, I think. Yeah, so let's try that. Centered horizontally, that is. Where is center again? Center layer is what I want, I think. And that's from widget center. And this is going to be wrong because the border is going to be wrong, I think. Yeah, that's not what we want, is it? So if I put the center layer around the border, I think we're going to be closer to what I want. That's better. Now why is this so big? There's a limit function somewhere. Maybe it's called h-limit. But that's not really what we want, right? I want to make sure that this only takes the space that it needs and nothing else. So why is this greedy? Is it because of the h border? Well, let's see if that's the problem, because maybe the h border is greedy and then it gets as big as it wants. Yeah, that seems to have been it. So is there a non-greedy h border? H border. Here it says fills all horizontal space, but that's not exactly what we want, is it? We wanted to fill as little horizontal space as possible. So how do we do this? See, someone else has joined. Welcome. Say hi in chat. If you have any questions, feel free to ask. Maybe this is actually fine. Yeah, if I give this all a bit of padding. C Vlad F hi. Is that the right way to pronounce that? Oh, C Vlad FP, now I got it. Hi. What was I going to do? Padding, yes. So let's do pad all 1 around the start, and do the same thing around, and by start I mean front, and let's do the same thing for the back. That's a bit better already, and now the H border is actually close. It's just Vlad or C Vlad, what are you working on today? So I'm working today on the beginnings of a little spaced repetition tool. It's a bit like Anki, but I want to have some declarative cards. And what I'm making now is just a little TUI that can scroll through the cards, as you can see here. There isn't much to see yet, obviously, but that's fine for now. Actually, you know what, this is fine. It's going to be more obvious what we want this to look like later. So this is definitely good enough for the first step of the project. So we have a little TUI to scroll through the cards. Good, next up. We want to be able to quote-unquote study the cards without repetition data. So it's not really studying, it's just it needs the right interface already. So we want to start with, for each card, we want to show the front, wait for the user to say, now I want to see the back. Then wait for the user to say, did I do well, not well, or was it too easy? And then we want to show the next card. So let's do the next piece. So I think what we'll do is in the state, we'll say, just remember which part of the card we're looking at the moment. Yeah, let's just do it, please. Now I need to build it with pedantic, so the compiler tells me what I need to change. I need to change something, otherwise it's not going to complain yet, because this is already built. Oh dear. Let's get rid of these already. Alright, so next up we need to add whether it's the front or the back that we're looking at in the state. So let's start with the front. Next up we need to somehow make a distinction between what we draw when there's a front or a back. So let's say if there is, we can do concat here. Oops. Oh, that was wrong. Like so. Yep, and now we don't want to show this part if there's only the front being shown. Does that work? Yeah. So now if I render it, it will only show me the front of the card. I can still go to the right, but that's not what we want at the moment. Yes, and then when it's the back, we also want to show these, no, when it's the back, we want to be able to have 3 buttons. Let's say bad, good, easy. Yeah, so B, G, and E for now. That's going to be fine. Let's say instead of, yeah, this is going to be wrong, isn't it? Okay, let's think about this. So if we're at the front state, then we want to make sure that there's only one button we can press, which is space to show the back. Okay, so we're going to have to case match on state front back. If there's a front shown, we want to be able to press Q still. Oops, to exit at any point. And if we press space, then we're gonna change the state cursor, sorry, not the cursor, but we're gonna just change the state front back to back. And then if we're looking at the back, we can press right. What's wrong with K-space? Is it just K-char like this? Yep, that was it. Alright, so now we see the card. I can press space to show both. Doesn't look nice, that's fine. Now I can press right, but when I press right, it should show the front again. So state front back is front. Alright, so space, right, yeah, this works. Let's remove the H border for now, because it's gonna mess with what it looks like. Yeah, that's better. Next up, we want to be able to instead of pressing right, we need to give it some sort of indication of whether it went well or not well. And I guess we'll go with what library am I using for the fancy border display in the console? It's called Brick. It's one of my favorite Haskell libraries. I gave plenty of talks actually about how to use this thing, so if you look for my name on YouTube, here we go. I've got a long lecture about how to make a text editor in Brick. I might try it on stream sometime, go for it. So have a look at this talk if you're interested in that sort of stuff. I'm going to put that link into chat so everyone else can have a look as well. There we go. Next up. Right, the indications of how easy something was. Okay. There's a really easy way to do this right now, which is with a little combinator. So let's finish a card with, let's say, let's call it difficulty, and we'll call it, no, what do you call that? Yeah, let's say difficulty. Card wrong, card correct, card easy. So finish card will be difficulty to event next state. Finish card. We will ignore the difficulty for now because we don't actually have a way to deal with recording it. And in that, when we finish a card, we're just gonna do whatever we did with when pressing the right button. So we have wrong, we have correct, and we have easy. Never mind that this is not exactly discoverable right now. You just need to work. It needs to work first. Alright, so we have our card. I can press space to show the back. I can press wrong, correct, or easy, and it all works. Okay, nice. Now, technically the next to do is done, but let's make it a little bit prettier because it's surprisingly difficult to see. So the way you make stuff have colors in Brick is using these attribute maps. So I'm gonna give an attribute for, no, wait a second. Here, we have attribute map. I can make it the default way of showing things a bit more clear. There we go. the map's default attribute to be returned when a name lookup fails, and the attribute that will be merged with successful lookups. Okay, so I think I can just, to really quick and dirty make this look nice, or nicer at least, is just say foreground right white. And we need to get those from somewhere. I thought there was a way to do this. Oh no, it's brick.util. Scusi. Brick.util. Yeah, okay, so I've got background. Now I need to import this module where the colors are defined. Cool. Now it should be a bit... Yeah, there we go. Now I can read this. Cool. Okay, so that's the next thing done. We have a way to scroll through the cards without the repetition data. Next up will be TUI with the repetition data. But first I need to commit this. A little TUI to study without any recorded repetition data. Cool. So next up is storing the repetition data in the database. But before we go there, I want to make the interface a little bit more discoverable. And the way we do that, I think, is just going to be to describe these three options of wrong, correct, and easy. Let's call this incorrect instead of wrong. That's fine. How do we do this? I think we're just going to be able to... Yeah, if I just put this all in a VBox again, and then say have a little HBox with descriptions. So I can say, for example, correct. See? Incorrect. Easy. What does that look like in practice? No, almost. Now I think I want to H-center that. There we go. So now I want to have a different information box based on what the state is. So we can say case state on back. If it's back, then that's what I want to show. If it's front, then I want to show show back using space. Yeah, looks nice. A bit more discoverable interface. So the next step will be to have a little SQLite database to store the repetition data in. Any questions so far? Okay, so for anything database, I usually like to use persistent. So I'm going to have a little module called spyrep.db, and I need to add some things to the dependency. So we need persistent and persistent SQLite. How did this go again? There must be an example here somewhere. Wasn't there a way to do that? Isn't there an examples module here somewhere? I don't really want to use my own project as examples, even though I definitely have done this before. Just because it would be nicer if the documentation was good and if I can figure it out by the documentation itself. Docs? Yeah, that's not it at all. Aha, easy. Ah, that's what I need. There we go. So we need these three. And then this, that's exactly what I need. And now I want a repetition data. And the repetition data will be a card, and I need some way of referring to the card, which is going to be, let's say, card ID, and then difficulty, and also when that happened. We'll need to have some access to time as well. So now we need to think about this card ID, right? How do we want to refer to cards? I think the best way to refer to a card is to have some sort of definition for a card, and then some way of hashing that definition. So the definition should be everything related to what you see. Hashing that definition should result in the card ID. And then we have a way to refer to that. If we ever change the card, then you would have to restart studying them, which is fine by me because that doesn't actually happen a lot. And that way you can actually have a reference of repetition data for cards that you don't even have anymore, which is also fine. We don't need these two. So this card def, I think we're gonna want a separate data structure for the actual card, because if you remember the example that I had this reverse true here in the card defs, and that would result in more cards. And actually, I think we don't need the maybe. Don't care about having difference between not defined and false. Okay, so back to the database because this is finally completed. Okay, now we need a way to refer to the difficulty, I think. No, that's not true. Repetition data. There's something wrong with brackets. Oh, that's because I haven't enabled quasi-quotes. See, there's something, this is something I don't really necessarily like about Haskell, which is this doesn't really tell you anything about the actual fix. So this is a bad error message, and now I happen to have some sort of cached map from bad error message to actual fix. But it doesn't really help if you don't have that, you see. Here again, this is a module. I just happen to know that we need to have persistent template added, and now it's in order. Okay, so I think we'll want to import the spyrep.card here, and this will contain the difficulty data then as well. What else went wrong here? Oh, I need to have template Haskell as well, and then it's going to tell me about a whole bunch more things I need. But first about these two. Okay, that's fine, we'll get to that in a moment. So we have card defs, we have card, and now I want to define card. We want to have a card ID, which will be, let's say, a SHA-256 hash of card contents. For now, let's just use a regular hash. I don't really care at the moment. And then we need to put the difficulty in this module as well. And we're going to need to write a bunch of instances, but that's also good. So we don't have a persist field SQL. So these are the kind of things I will need to implement, but first I want to have some deriving things. Good. Any questions so far? Because now the fancy stuff is going to happen, and by fancy I mean fancy to the compiler, not actual fancy Haskell. Okay, so we will want a hash card, which will take a card and turn it into a card ID. And this is the essence of the project here. Now, how do you Haskell SHA-256? Fast, pure, practical. That seems too good to be true. Hash a strict byte string into a digest byte string. That seems nice, and then I can probably turn this into a hex somehow. Yep, this seems good enough to me. So let's add it here. Nice, it's in Stackage as well. So I'm guessing... No, I was wrong. So I was guessing that there was some sort of other package. Oh, there they are. So there are some other packages. And there is a... Okay, yeah, that's fine. So then we're going to use a byte string here, and it's going to be 32 bytes exactly, ideally. Not ideally, it must be 32 bytes exactly. How do we guarantee that? A word 64 is 8 bytes exactly, so we could actually do that. That seems a bit silly to me. And we want another one for the length. How do we do this? Okay, let's not go very far with the type safetiness and just keep a byte string. We can always have a validity instance. In fact, let's do that. And the reason I'm not being annoyed by this error message is because it's in a different module, which means, and that module imports this one, which means this one was fine. So I can just continue working on the module right here before fixing the rest of the error messages. Okay, so we need validity byte string, and we'll probably need validity text. Now I want to define that this card ID is valid. I need generic, which means I need derived generic. I need GSC generics. I need to import data with byte string. I already have that. So I think the cards are going to be small enough so we don't have to care about lazy versus strict, so we're going to make it all strict. So then I can say validate is generic validate, and then we're going to add something else, but first I need record wild cards. Word64 is in data.word. I see that some more people have joined. If you have any questions, feel free to ask them in chat. Also say hi if you like. So now we want to say that sp.length card ID SHA-56 is equal to no, that's a good question. What does that measure in bytes or the length of a byte string? I guess that's the number of bytes, so then it's going to be 32, and I have to declare that as a constraint. Like so. And we need to import qualified data.byte string as sp. Alright, this seems to work. Now, I need a little bio break, so I will be back in 2 minutes. And we're back. So where were we? I just defined the card ID. Let's really quickly implement the hash as well. So it's important that this hash never changes over the time of the development of the application. So that means either we should make sure it's backward compatible, or we should only start using the application once we're done with the card design. So let's go with the latter to make things easy for now and implement this. To do that, we need some sort of lazy byte string here. No, we're going to use this one, so I have a strict byte string. So I need to be able to encode this text as bytes. Oops. And the reason why I want to make a distinction between card def and card is because I will want to have something like card def reverse, so that you can have per card reversals as well. So this is where the declarativeness comes in, and this is not a required field but an optional field with the false. Okay, now implementing this, so we will want to import this thing. What happened? That's 56. So we want to find some sort of byte string that we will hash. And then use SHA-256.hash. Of that byte string, and then also the byte string length of the byte string. This is going to get me into trouble, isn't it? No, it's going to be fine. So the reason why I thought it's going to get me into trouble is because we need to turn this into a single thing that we put in the database. And I'm not sure how to do that yet. The reason is you cannot have two separate fields of the database into a persist field. So we'll need to turn this into either a different encoding of another byte string, where maybe the first 32 bytes are the SHA-256 and the next 8 bytes are going to be the length. Not 8 bytes. Is that 8 bytes? Yeah, that is 8 bytes. Geez. That's probably not going to be necessary. Okay, it doesn't matter. Does it matter? That's a lot of bytes. This many megabytes. This many gigabytes. Yeah, there is no way I'm gonna have this many gigabytes of one card. Even 4 gigabytes. Yeah, so let's just make it a bit shorter. We don't care. Okay, next up. Fix this. It's gonna give me an int. That's exactly what I want, actually. So how do I turn an int into an int32? Or even an int16? Yeah, let's make it an int16. I don't really care. And we also actually don't want an int either. I want a word. So let's make this a word 16. And how do I turn those into again? There must be some way of doing this. I think there's something like from integral. I guess that will work. It's not a nice function to use, but maybe there is a nice version of length, like generic length. No, there isn't. Okay. So now we need to encode the card contents as a byte string. So I was thinking just encode UTF-8 card front. And then we can do sb.concat keys, like so. Good enough for me. Now the problem is going to be if we ever add something else there, but that's going to be fine for now. Those are problems for future SID. Okay, so now we've got our card ID. Now we need to implement persist field SQL card ID. Now the question is, do we want to store that efficiently or do we want to store it as a string? I think efficiently is going to be fine. So we can say render card ID and then parse card ID. We'll need both of these. SQL type proxy equals SQL type proxy of byte string. And now we need to import database persist again. Oh no, just persist, but also the one.sql, because we have to implement persist field SQL to describe how it's going to be stored in a database, like what type, and then also persist field, which is going to do the actual translations. So I can think we can do toPersist field is toPersist field of render card ID, and then we're missing one, and we also need data.proxy. Let's have a look. Which one is it? Ah, persist value. Whoops. And then we also want from persist value, which is going to be get a byte string first, and then case parse card ID. Let's do this a bit more verbose, like so. And actually, this is a nice opportunity to use the fish operator. Yay! Okay, now implement these two. To render a card ID, here's the thing. We need to, these are 32, yeah, these are going to be 32 bytes. So that's going to be nice in the sense that we can just put them behind each other. And then we need to turn the word 16 into a byte string. How does that work? There must be a way to do that. Aha, there we go. That's what we need. So that's in bytestring.builder. I've actually never used these bytestring builders. Interesting problem to run into. I see there are a few people watching. That's really nice. If anyone has any questions, feel free to ask them. I'd be happy to answer them on stream, and I'm guessing there will be other people with similar questions, so go ahead. Also, if anyone's feeling like doing some pair programming, contact me. Maybe we can make it happen. Okay, so we want to store this word 64, not as a decimal encoding. Also not like that. Also not hexadecimal. What is fixed? So what does little endian versus big endian mean again? In practice, so like if you have a normal byte string, will it be encoded as little endian or big endian? Oh, so this is going to store the number. That's also not what we want, is it? Wait a second, then the next question is going to be, how do we parse these things? Okay, this seems like exactly the kind of thing that I need a test for. So let's get this building real quick, and then we'll get to the next part. We'll get to the test. This is not efficient, that's fine. Lambda case, nice. What else? Byte-string building, yeah, we'll need that in a moment, so I'll just comment to that. What else? Persist field SQL. Of difficulty, we'll just use that via text. Then we also need parse difficulty. I'll just have it return an either, just because it doesn't really matter. Unknown difficulty. Okay, now the nice thing is there are some property testing libraries for this. So once we get this building, the testing should be rather easy. Oh nice, more stuff to copy. Just keeps coming, doesn't it? Dance with the compiler. Oh, nice. Now it works. Alright, this compiles. So, next up, tests. Do we already have a test suite? We do. Okay. So let's have a look at the tests. This is not what we want. This is something I copy-paste every time because I have no idea how you would remember this. It's a little module that generates, a little pragma, I guess, that generates the test suite entry point. Card spec, yeah, here we go. Test.hspec, spec. Now I should have the beginnings of a test suite. I don't need this right now, so we need hspec. And then what do we want to start testing? So we need a few things. We need to be able to generate all these fields. So we need to have instance. No, we need to make. Let's make a module for this. So we'll have spirep card gen. So we want instance gen valid card, and we can't have gen unchecked here, so we need to do something like gen valid is gen valid structurally without extra checking. And if you don't know what I'm doing here, this is validity-based testing. If you have any questions about that, I have plenty of talks about it. it basically gets you shrinking and generators for free entirely. And it gets you a bunch of test suites for free as well. So actually most of what we're going to be doing right now is entirely boilerplate, and all the tests are just going to be generated, which is really nice. So in particular, here we have test.validity, which is what we'll need. And then we want genValidity HSpec persistent as well. So this gets you most of the base things for free, but now I want to have these ones, so I can just say that my card ID and my difficulty are just persist fields. I will need this type applications to be able to use it. This will just test for me that the round trip works and that it just makes sense. Now, one thing that's really important to add as well, if you're doing this, is to have another test to make sure that the generators are valid as well. And the cards don't need to be in the database, so that makes things easier. We'll implement those later. Difficulty is easy. And these come from Spidable card. Okay, does this make sense so far? If not, now is the time to ask. No questions. That's handy. And obviously you can only generate valid things if you know what valid means, so we need a validity instance for card. And we need one for difficulty as well. And we need a generic instance to be able to derive the generators for free. There we go. Oh no, not yet. We almost have a failing test, come on. Oh, it's not invalid, but invalid. There we go, now we have a failing test case. Alright, and you can see that generating valid card IDs fails because obviously this is not defined yet. And then doing round trips for card IDs fails as well because I haven't implemented that yet. So how do we generate valid card IDs? I'm thinking we just hash some cards. So we can say shrinking for card IDs doesn't make sense because they're just hashes. So I think this will be a good instance to have. Okay, so this one passes as well now. The generators are done for now. So next step will be to... Oh, and this also checks, by the way, that whenever... So we've already tested now by generating valid card IDs that hashing a card gives you a valid card ID, which is pretty cool. But we're going to also do that specifically by saying hash card, it produces valid card IDs. And a card ID could technically be invalid because the type system here doesn't guarantee that this byte string, where is it? This byte string is exactly 32 bytes. But if I just test it, that's good enough for my sake. And I can just say produces valids on valids, and we have a test suite for it. There we go. And it passes as well. That's nice. Next up is we want to implement these two. These are going to be the difficult pieces. So if I can turn a word 16 into two word 8s, I think that'll already do what I want. If anyone knows how to do that, please tell me, because that's the difficult part right now. These are all a bit separate. Isn't there a built-in way to do this? Alternatively, I can just leave away the length. Yeah, I'm not getting any safety here, am I? No, of course not. Okay, then I'm gonna make it easy for myself. No, wait a second, do I really want to do that? Because this is the kind of decision that's gonna impact the rest of the code base, the future of the project, because if this ever needs to be changed, it's backward incompatible. So is there a really easy way to do this? What is X? No, that's not it. Bits. Storable? No, this is even more low level than I had in mind. Finite bits and bits are promising. These don't really help so far, do they? This is for individual bits, so I guess we can just. It doesn't matter. We're gonna be testing this, so it's gonna be fine. So parse card ID. There we go. So we can turn these into a list very easily. And if it's anything else than a list of exactly, well, it's 32 bytes plus 2. So we expect 34 bytes exactly. So the first okay, so we can already say if case sb.length is 34, then we can continue. Otherwise, invalid bytes card ID length. We can turn them into words. By doing sb.unpack of that. Okay, and now we can take the first, so the SHA words are take 32 WS, and then the length words are going to be take to, drop 32 WS. Is there a split at? Of course there is, nice. So we want to split at 32, I guess. Yes, because 0 would be at the start. Good, good. And we need that little text as T as well. Chat is awful quiet this time, this stream. If you have any questions, just put them in chat. I'm sure others will have similar questions. Okie-doo. Now we want to turn them into, so the SHA words are going to be easy. We can just say card ID SHA-256 is sv.pack those again. And the other ones, so we've got 2 words exactly, or we should, we can, yeah, turn them back. So we should have case length words of 1 and LW2, and anything else will be an so this will not happen, but it's better to not error anyway. Invalid word length, number of length bytes. They're not words, they're bytes. They're word 8s. So it's missing a value here. Oh, and we should probably make those strict as well. There we go, now it's a compile error. So now we've got these 2, and I think in data.bits is the solution to my problem. This is not a problem I thought I would be solving right now. But here we are. So we can shift. So if I turn them both into word 16s first, so LB1 16 is from integral LB1. This is safe. So now they're both word 16s instead of word 8s. And then I can do card ID length is shift L LB1 116 by 8 bits plus LB2 116, LB2 16. Alright, and now to see if this works, we need to also implement render card ID, and if they round trip, then I think we have the solution to the problem entirely. This we don't need here right now. Byte string, where was it? I guess this is a little Indian encoding, I'm not sure. Doesn't really matter. To render the card ID, we want to, where's the byte string builder again? How do we turn a builder into a byte string? No, I don't want a lazy one. I guess I'll get a lazy one, so then I need to turn it back into strings, strict ones as well. So, sbb.toLazyByteString, and then I want lb.from, to strict. And now I need to make my builder, and the builder is going to be relatively simple, I hope. It's just byte string, so turn this into a builder, and then add on the word 16 big Indian. I don't know if that's the one, but we'll see by the test output whether that's the one. Looks like that was right. Cool. So now let's make this a bit more readable. Like so. Alright, so we've got all the undefines implemented, and we've got our database. So little database schema for repetition data. And we'll use STF again. So next thing I want to do is be able to turn the card defs into cards. So let's say, it's not resolve card defs, but what do you call that? What is it called when you turn a declaration into the thing itself? Now let's say resolve. And in order to know whether this will have worked, or not necessarily worked, but like at least do something, we're gonna say this needs to produce valid cards. And this will require a little bit of, yep, we need to implement some more generators. Nice. Luckily those are really easy to make. Because we can just do this. And we have our generators. Oh, almost. Nothing special. Okay, so now we just have to fill in the undefined and our thing will probably work. We'll also need a function called reverse card, which turns a card into another card. Card front is card back, and card back is card front. And the reason we want these reversals as well is so that when you learn German, for example, you can also, you can do it so that you can only, wow, words. When you're studying German, you have your vocabulary that you study from German to whatever other language you're used to, but then also you want to be able to also do the translation the other way. And that's where in that situation, you want to only write down the card once and just declare that you also want to study the reverse one, and then have that happen automatically. So this is where the declarativeness comes in. And I'm just gonna have a really cheap test for this reversal as well. There we go. Good. Now, if we have some card definitions, so I think we can do resolve card def as well, which is also something we need. However, this will return a list of cards because we also need the reverse, and we also need the default value for the reversal. Default reverse card def. And before we get started, I'm also gonna write a little test for that. There we go, we have a test. The test doesn't do much, but at least it tests that it's not implemented as undefined. Oh, and we need produces valids on valids 2 here. There we go, and so now we have some tests to fix, and when the tests are fixed, hopefully our code works. Okay, so what is the opposite of reverse? Yeah, let's call it that, I don't care. Card front is card def front, card back is card def back, and then reverse card is reverse of the right way around one. And now the question is, do reversal will be default reverse. Now it is going to come in handy that there are maybes here. So actually, yeah. Because in this case it does matter whether it's a maybe or not. Because if there's a true and the default is also true, then it still has to be true. If there's a false and the default is true, then the specific one is not going to be reversed, and if there is nothing, then it's just going to be the default one. So now we can do from maybe of this with card def reverse like so, and then we can say right way around card plus plus reverse card if do reversal. Ta-da! And now we need data maybe. Okay, this seems to compile. Resolve card defs, that's where we want to say concat map resolve card defs reverse card defs cards. Super. Okay, so while this compiles, the next step will be to actually start using this database. So I'm gonna commit this and then take a little bio break. Solving. All right, be right back. And we're back. So I think the very next step right now is to use this resolution. So first some little refactors. So here we get these card defs, and actually we want just cards instead of card defs right there. So when we're building the initial state, we want to resolve the card defs here first. Yeah. And then here we use regular cards. All right, so now if we try and study, yep, exactly, we get the two cards right next to each other, which is exactly not what we want. We probably want some randomness here, but that's fine. Ooh, this is an interesting way of painting that. Anywho, so that's a little refactor. And the next thing I want to do is store the repetition data, but not actually make any decisions about it. And then I have to start looking into how these spaced repetition tools usually work. So, how did that work again? There's a standard way of doing SQLite stuff. Where is it? Yep. So I import database persist SQLite, and then I want to say with SQLite pool let's just do it like this. Doesn't really matter, it's just for testing right now, and by testing I mean trying it out. Number of connections, only one connection because it's SQLite, and we have a pool. And we probably want to put this pool in the state, don't we? Yeah, let's say so. So that we can actually store stuff in the database. Okay, something is probably wrong now. Yep, because we can no longer show the state. We also don't want to print the state here if that's the case. Yeah, forget about void. No, actually, is there anything special we need to do at the end? Not at the moment, so let's just use void. Monad logger. Oh, right, so we need this SQLite, this with SQLite pool can do some logging, and we also need to set up the migration first. So we need to run run no logging key, because if you do any logging while there's a TUI, everything will go haywire. And then this will all need to be in LIO. I think the resolve file is smarter about that. Yeah, closer at least. Defined but not used. Ah, right. Okay, and now we need to run the migration, and that's using run as no. Run SQLite? No. How do you use these again? I should probably show you what I'm looking up. I'm looking for this the function that takes the pool and a function to do the actual query. I think it was called run pool. No, run SQL pool. Okay, nice. And the first thing we want to run there is run SQL pool with the migrations, and the migrations are in the database module. Migrate all. Does that work? Huh. Run migration quiet. Let's just do the normal one first. This seems to compile. Now, if I run this, it did do the migration, and I have an SQLite 3 database. Cool. There's no repetition data, that's fine. So I actually should call this repetition, not repetition data. Very fancy. Now, I think the only thing that's left to do now is insert this data whenever we have this finish card. So the query is going to be insert repetition with hash card of this current. No, that's the cursor, not the current. And so we need to get the current card like so. Hash that one. That's the card ID. Get the difficulty from here. And then repetition timestamp is now, and now we can get using list.io get current time. Is repetition with an I or an E? Repetition. It's with an E. Aha. Now, why does it don't know about this? Repetition is with an I as well. This is a difficult word to spell. Repetition. Wow, still was wrong. Okay, then we need data.time, and we need database persists, which contains the insert function, I think. Yeah, okay, so the reason why this doesn't actually do anything, or it doesn't compile rather, is because it doesn't know which kind of database to make a query for, but that'll fix itself when we do run SQL pool of query state connection pool. Nice. Okay, let's IO this. And we don't actually need the result. We don't need the ID of the repetition. Okay, so now if I remove the SQLite 3 database, run it, and then say das Umdenken is the change of, I don't know what this is, the rethinking. Okay, so I didn't know this, so it's incorrect. Now I know that the rethinking is das Umdenken, so let's say correct, but that doesn't really help much. Okay, now I press Q, and there should be 2 rows in this database. And there are, nice. So we've got this blob, which is the card, but they're obviously not the same card because it's the front and the back version of it. Let's see if we can find a pattern in this binary data. So the last 2, these are the length, they should be equal. Yeah, that makes sense. And then the first and the second part, this should be entirely different because this is the SHA-256. And they are entirely different. Lovely. This is incorrect and correct. Timestamps look fine. I think we've got ourselves a repetition data. Nice. Okay, I think this is it. So this was to do 3. And the next to do would be figure out how to use the repetition data in order to decide what cards to study in this session. But I think this is enough for today. So use the next step would be learn about using repetition data to decide which cards to study next. And I will look that up by myself. I think I'm gonna end the stream here. I think we've got all our goals completed. This was very successful, so I'll clock this out. Storing repetition data. There we go. Thank you all for watching. This is going to be on YouTube relatively soon as well. So if you haven't been able to watch the stream, you'll be able to follow along over there. All right, any questions before I go? All right, then I'll stop here. See you guys in the next stream.